Hello everyone, my name is Tim and I'm new with Perennia. I started in October, have taken over Rosie's position as a vegetable specialist. Please don't hold it against me. I think, yeah. So I'm going to be talking about potassium, calcium and magnesium, some basic compost calculations, and a couple of other things. So I'm going to break my presentation into 4 parts, talk about plant nutrient acquisition, talk about my minerals, have a look at a broccoli as kind of a test crop, kind of just to track nutrients over time, and then finally look at some calculations. So to be a bit controversial at the beginning, plants suck at extracting nutrients by themselves. So plants don't do anything by themselves. They work in combination with biotic factors in the soil like mycorrhizae. They use bacteria through the rhizophagy cycle and other methods to mineralize nutrients. They also use water flow, as Caitlin alluded to bring nutrients to them, you know? So when a plant is in the ground, its roots are only in contact with 3% of the volume of the soil. And if you have a crop like a brassica, a beet, or spinach, it doesn't make mycorrhizal associations. So this picture on the right-hand side here, the plant on the left doesn't have mycorrhizal associations and the plant on the right does. Picture this as your brassica. Your brassica is competing with weeds that do have mycorrhizal associations. So how do you make sure that the brassica, even with its smaller root system or lesser ability to mine nutrients from the soil, how's it going to do that? So Caitlin has already talked about these. She did a great job. The only thing I'd like to add is that mass flow is only happening when the plant is actively transpiring and growing. So it's very much determined by environmental conditions, temperature, but it's important to have plants actively growing. That's the only time that the water is moving through the plants. Okay, and I have the same graph that Caitlin had. The only other thing I'd highlight, so in this example, this example was a corn plant in a fertile loam. It's going to be different for every plant, and this is just it's an indicator, but it's not going to be exactly the same for every crop. So in this example, mass flow is doing 78% of the nutrient acquisition. So after that, it's root interception, which is 13%, and diffusion is only 9%. So really, mass flow is critical, and that's only happening when your plants are actively growing. So mass flow is water movement through the soil. And what does that mean? You're not growing in a wetland. You don't want to have your soil completely saturated with water. You want to have something similar to this on the left-hand side. So you want to have a film of water over all of your aggregates. You want to have adequate soil moisture, but not excessive water in your soil. And if you look at the very top of this picture, you can see there's a constant film of water through all of the aggregation in the soil. If you have a dry spot, that film is stopped and the water can't proceed through. You know, the mass flow is an unbroken chain from the plant through the soil. And if you have a dry spot, you're breaking the chain. And so you have less ability for mass flow to work, essentially. This picture on the right-hand side, so this talks about something that Caitlin alluded to as well. You have your clay mineral and your organic matter aggregate there. They're negatively charged. They have cation exchange sites where they will exchange cations. If you have a soil that has excessive calcium and magnesium in it, those calcium and magnesium ions, because they have a stronger charge, like Caitlin's example, they're going to rob those exchange sites of other nutrients. So if you have excessive levels of calcium and magnesium in your soil, that reduces the ability for other nutrients to be present right next to your roots, because those exchange sites have been robbed from what they were and have been replaced with the excess calcium and magnesium. So it's important to have a balanced amount of nutrition in your soil system. Okay. Gosh. Okay, so on to potassium. So in my mind, potassium is about quality. So it's about structural strength in cereals. It's about improved stress response. aids in disease and insect resistances, helps with photosynthesis. It's held via cation exchange sites. So soils low in organic matter or these cation exchange sites aren't going to be able to hold as much potassium in the system. So again, it's really important to have organic matter in your system to be able to hold these minerals in place. Kind of like phosphorus though, it can get fixed inside clays. So potassium can actually get stuck inside of clays and then only made available as those clays weather and the potassium is released. Okay, so this is what a potassium deficiency looks like generally. You'll see it on the margins of the leaf. So you'll get chlorosis to necrosis on the margins of your leaf. You'll also get a kind of shotgun pattern through the leaf itself with chlorosis. So I have lettuce, a cucumber down here, tomato up on the top right. But it also affects fruit development. So you can get yellow shouldering because of potassium deficiency as well as sun scald and other things. But it has a crucial role in fruit maturity. So onto calcium. Calcium, in my mind, I view it as kind of a bouncer. It stabilizes cell walls, and it provides a barrier to disease entry. It's heavily dependent on mass flow and root interception, and it is an equilibrium maintained between the soil solution and the exchangeable pool. Calcium deficiencies are generally due to a lack of water and not a lack of calcium itself. And that's just, as I was talking about with mass flow, you need water present in the soil for those nutrients to get to the plant. So generally you don't see too many calcium deficiencies on leaves. If you do, it looks like a kind of a rot on the margins of the leaf. But I'm sure everyone's familiar with blossom end rot of tomatoes. It'll affect cucurbits and other solanaceous crops too. And magnesium. So magnesium is a catalyst in the soil. It's part of the central core of chlorophyll, and it helps activate specific enzyme sites as a cofactor. It's held at cation exchange sites on clays and organic matter. It's often present with calcium in hard water. So if you have hard water and you're using that for your irrigation, you're most likely applying a decent amount of magnesium as well, which can clog irrigation lines. It's not good if you're using hard water too much. For the forage guys though, magnesium deficiency in grass causes grass tetany in animals, which kills cows, and so it has to be actively managed in animal systems. And this is what it looks like. You'll get chlorosis between the veins of the leaves. So it has a kind of unique look. Even in the corn plant at the top, you can see that interveinal chlorosis running all the way through. Okay. So a bit of information about the minerals. Now to look at an example crop. So I'm going to be looking at brassicas here. So I have this table. It's a proportion of marketable crop removed by brassicas. So if you're growing broccoli, when you harvest that broccoli, how much of the nutrients are you removing from the field? So for broccoli, you're only removing 22% of the nutrients from the field in that head of broccoli. Something like a white cabbage, you're removing a lot more. 67% of the nutrients are being taken off the field. The main reason I wanted to show you guys this is just to think about the amount of nutrients that you leave in your field after you harvest a crop. So obviously you don't harvest all of your broccoli at once. It takes a couple weeks for all of them to mature, but there's a lot of nutrients left in that plant that can be recycled through your system, through flail mowing, incorporating, or even composting. You can save a lot of nutrients. If your broccoli plant is uptaken 200 pounds of nitrogen, only about 40% of that is being removed. So you have 160 pounds still in your system that you can play with. Okay, and then, oh my gosh. Okay, so this is a macronutrient uptake. So this is specifically for broccoli. 22% of the minerals are being taken from your field. On a macronutrient scale, what does that mean? So 24% of your nitrogen has been removed from your field, but only 2% of your calcium has been removed from your field. 15% of your potassium. The main thing I want to show with this is just that there's a lot in your system still. So you harvest your brassica, but you have a lot to play with, you know, and you can think about ways to make use of those nutrients. Obviously, you're going to lose some to volatilization, and weeds are going to take some of that up as the plants decompose, but there's still nutrients in your system. So this just shows macronutrient uptake over time in broccoli specifically. So the top bar there is nitrogen, then you have potassium, then calcium, then phosphorus and magnesium. So you can see that the nutrient acquisition, it ramps up over time up to the split between the vegetative stage and the reproductive stage. And then nutrient uptake drops down again. So this just echoes the points that Caitlin and Rosie made about not front-loading all of your nutrients. If I would apply, so it starts at 20 days after transplanting. If I would apply my nutrients the day before I transplant, I'm front-loading a ton of nutrients that my plant doesn't actually need until 30 to 40 to 50 days into its life cycle. So if you can think about ways to split apply your nutrients through fertigation or through delayed fertilizer, you're not just fertilizing weeds. You know, if I put on all of my nutrients up front, the weeds will gladly take it up. So nobody wants that. Okay, so to summarize so far, adequate soil moisture is essential for nutrient uptake. The majority happens through mass flow. Excessive soil nutrients hog exchange sites present in clays and organic matter, reducing availability of other nutrients. The non-harvested portion of your crop is a nutrient-rich resource that can be recycled. Nutrient uptake generally follows a bell-shaped curve, as the example I had with the broccoli shows. Potassium is about quality, calcium acts as a bouncer in your system, and magnesium is a cofactor catalyst. So how do you go from a seeding plan to a nutrient management plan? Got to make sure you have a soil test. You need to know the area, so measure your beds, measure your field. Decide on what fertilizers are right for you. Are you an organic system? Are you a conventional system? Do you apply all of your fertility through your drip system? You know, like the fertilizers you choose are heavily dependent on the limitations of your farm. You're going to do your calculations and convert to an application method that makes sense to you. We talk about kilograms per hectare, and maybe you order your compost in tons. You know, I want to get 10 tons of compost, but you don't apply it generally by weight. You would apply it by volume. So you would apply it by the tractor bucket or by a wheelbarrow. So you need to be able to make that conversion as well. So I just created a mock farm. It just has 4 blocks. So a brassica block, a solanaceous block, cucurbit block, and a leafy green block. There's 10 beds per block. Each bed is 30 inches wide by 100 feet long. I can't do imperial, I just do metric. So my first step is to convert units into metric. In my mind, it's very important to use metric. That's what the soil test uses. So you're going to get results in kilograms per hectare. So it just makes sense to convert things right at the get-go. But there are some die-hard imperial guys here, I'm sure. Yeah. Yeah. So for me, each block is 232 meters squared of growing space. I have a total growing area of just under 1/10 of a hectare. So I have a look at my soil test report. In hindsight, I should have used the same soil test report you guys have in your paper. I didn't. Don't hold that against me. But the most important thing I want to mention here is you have your recommended nutrients at the bottom. You notice they're in kilograms per hectare. And as Rosie said, the nitrogen is a recommendation based on the crop to be grown. So my crop to be grown was mixed garden. I mean, that's a wide range of crops. So I have this table here, and this table is from the NCRS handout. I think this was emailed to you last week. So this uses a low, medium, and high nitrogen need layout. So I'm going to use this for my nitrogen requirements. Similarly, this P205 recommendation, that is based on a mixed garden. We have some handouts over here which are broken down to specific crops. So if you're just growing broccoli, you can use this and it's going to be a lot more accurate for you. This is from Cornell, so they don't use the Malic 3 like we do. But as Rosie said, you can still use the low, medium, and high to kind of gauge where you should be. Okay, so for my 4 blocks, these are the recommendations I came to. And it's important to note that the American table is in pounds per acre. So that's being converted to kilograms per hectare. It's really crucial to make sure all of your, everything's in the same units all the way through. So my brassica block is going to be the heaviest feeding. That's 225 kilograms per hectare of nitrogen. And then they all have the same phosphorus and potassium requirements. And then the nitrogen requirement changes per block. I'm just going to be using the first block all the way through, so you don't need to worry about the other blocks here. So we've been using kilograms per hectare up until this point, but it makes sense to just look at your individual farm. So block 1, my brassica block, I have 225 kilograms per hectare. My block is only 232 meters squared. So that works out to 5.22 kilograms of nitrogen, 5.8 kilograms of phosphorus, and 2.2 kilograms of potassium. I've listed out the other blocks there. So my total nutrient requirements for the farm are 15 kilograms of nitrogen, 23 kilograms of potassium, and 8.8 kilograms of, 23 kilograms of phosphorus, 8.8 kilograms of potassium. You guys are going to be working in much bigger numbers than I am, but this is just an example. So this is a compost analysis done by the NSDA of a local compost. It's a seaweed compost, and I want to highlight a couple things here. So you'll notice there are 2 columns. There's an as-received column and a dry basis column. The as-received column has your moisture in it. The dry basis doesn't have any moisture. Obviously, it's dry. So why do they give you the 2 columns? The dry basis is great if you want to compare different composts. So each compost has a different moisture rating in it. So you're not comparing apples to apples if you're comparing 2 composts at different moisture values. If you want to compare different composts to see what's in them, use the dry basis. Other than that, it's just confusing when you want to do your calculations. So you have your, it lists your pH. We have very acidic soils, so it's always nice to have something that is a little alkaline. So I'm happy to see that. It has a nitrogen percentage. So this nitrogen is the total nitrogen in your compost. Unlike a soil test, not all of that is available. So in your soil test, the phosphorus, it's all available to you. It's all plant available, sorry. The nitrogen needs to be mineralized for it to be available. So I'll talk about that a little bit more in a minute. The other thing I want to mention here is you'll notice your potassium and your phosphorus, they're broken into elemental potassium and K2O. So the soil test makes recommendations in K2O or P2O5, and that's what we're going to be using all the way through. There's a conversion factor to convert between these 2. It doesn't really matter which one you use as long as you're using the same units all the way through and making sure that they match your soil test. Okay. Oh gosh, okay. So I just have the compost analysis up at the top left again. And on the right here, this table is from the how to interpret a compost analysis. So as I said, not all of your nitrogen is available in the first year. It has to be mineralized. So this table it outlines what is the carbon to nitrogen ratio of your compost and what is the total nitrogen percentage in your compost. So if you have a look at the example, our nitrogen is 0.98% nitrogen, and the carbon to nitrogen ratio is 11.2. So looking at the table, that means that we only have 5% of our nitrogen that's going to be mineralized in the first year. Generally, 50% of your phosphorus is mineralized in the first year, and 100% of your potassium is mineralized in your first year. So going from our as-received compost values, the amount of plant available nutrients for nitrogen drops dramatically. So this is the amount of plant available nitrogen, phosphorus, and potassium we have in our first year. And just as an aside, you can see the nitrogen content is quite low. If I wanted to meet the nitrogen requirements of my brassica crop solely from this compost, I would need to apply 10 tons of compost to my 232 meters squared, which would be 96 kilograms of phosphorus, which would, you'd be destroying some river systems if you did that. Okay, so how much compost can I add without excessive phosphorus addition? So I need 5.8 kilograms of phosphorus for this block. My fertilizer concentration is 0.092% phosphorus, which means I can apply a maximum of 630 kilograms to not over-apply phosphorus. So at 630 kilograms, I use the same equation to figure out my nitrogen and my potassium. So that means I'm meeting my phosphorus requirements, but I'm not meeting my nitrogen or potassium requirements. So in this example, I'm getting 315 grams of nitrogen. I need 5.22 kilograms. So I'd like to add, if you have nitrogen credits from cover crops, from compost you applied the previous year, or from the previous crop that was in your system, say you were growing spinach and you till in your spinach, you're going to get a little bit of nitrogen from that. So if you have other nitrogen additions, they would be added on the right-hand side here. Because we don't in this model system, this is the nitrogen and potassium we still need. Oh my gosh.
So is the organic matter level that you mentioned giving one per 1%, you had a range?
Yeah, 15 to 20
Is that
kilograms.
the best measure of what you can credit previous compost and cover crop applications?
That's specific to the soil. So the compost, you're going to get about 10% nitrogen mineralization per year,
Right.
roughly. But yeah, the soil, as Rosie said, your soil is going to be mineralizing organic matter. So you're going to be getting 15 to 20 kilograms per percent organic matter every year. That is in your system, but you also don't want to be harvesting your organic matter in your system. You don't want to rely on that too much. I should have maybe accounted for it here a little bit. I didn't because I don't want to be, I don't want to use too much of that nitrogen if I can help it. It's going to be mineralized from the organic matter in my soil, but I want it to be replaced as well. So I'm not every year reducing the amount of organic matter I have in my system, if that makes sense.
Yes. So the only 10% of the nitrogen in the compost, your credit is going to this crop, and the rest is in the form of relatively stable organic matter that's in the soil. So the question, I guess, is whether you're sort of keeping track of your compost additions and have a fancy spreadsheet of what you're expecting year over year from past compost additions, or whether you're just measuring your organic matter on a regular basis and using that as a
no, that's a great question.
Fill in that blank that
Yeah, and you have to account for your compost additions generally for at least 3 years after you apply them. Okay. And the same thing for manures. So manures, more of it is mineralized than a mature compost, but you're still going to have at least 3 years worth of mineralization from that one manure application. So next year, when you do your nutrient management plan, you're going to have to account for the compost you applied this year. It's really hard to say exactly how much is going to mineralize because it depends on, the climatic conditions that year, the amount of rainfall we got, the temperature. Essentially, it's not a perfect system, and you're going to have to make adaptations. See if you had any nitrogen deficiencies this year, you know that you need to be applying more next year. It's an adaptive system, and so you need to make concessions for that every year. So to fill the void of nitrogen and potassium, I just chose 2 random amendments. One is pure nitrogen, one is pure potassium. And again, I figured out I need 35 kilograms of blood meal to meet my nitrogen requirements, 10 kilograms of seaweed extract to meet my potassium requirements. And as I said, you have a lot of leeway to decide when you want to apply these. So maybe you could split up your nitrogen into, I'm going to front load half of it, and then I'm going to apply the rest as a fertigation 30 days after transplants, something like that. So this nitrogen application, you can break it up and apply it as the crop needs it. Don't just apply it all up front. So how do you apply your compost? Generally, we buy compost in terms of weight, but you apply it by volume. So for that, you need the bulk density of the compost, and they don't tell you that on the compost analysis. There's a bucket method, which is quick and easy. Washington State University uses it. Essentially, you use a 5-gallon bucket, you make 3 marks in it, and you fill it with compost, tap it down, fill it with compost, and you weigh it, multiply it by 40, and it gives you a very good approximation of what the bulk density of your compost is. Unfortunately, it's in pounds per cubic yard, but apart from that, it's all good. So, so for our example, we were going to apply 630 kilograms of compost. That's about 1,400 pounds. We did our bucket test. That gave us a bulk density of 900 pounds per cubic yard. So that equals 1.54 cubic yards per block, which is 42 cubic feet, which is roughly 1 4 cubic foot wheelbarrow per bed. So from this is a very basic example, but it tells you how much compost you need to apply in a volume, and also the other fertilizers, you're generally going to be applying them by weight. Fill up a bucket, and it's going to be 5 kilograms per bed, for example, for the granular fertilizer. But that's it. So that's my presentation. Any questions? No? Okay, well, thank you.